Hi there, and welcome to tutorial 3, where we're going to build on tutorial 2, where we were discussing lists, and now we're going to create and access and modify lists. As always, this is just a small portion of the things that Mathematica can do. Um, let's get started. So, one of the things that you could do to get started is to evaluate all the cells in the notebook, and then you would see all the outputs from the from it. So this doesn't show this program is not showing what happens when I open this menu. When you click on the evaluation menu and you say there's an option to evaluate the notebook. When you click that button, that will evaluate every single thing in the notebook in order. We'll talk a little bit more about the order next time. So let's talk about the table command again. So we said the table command was very useful for making lists. Well, what we focused on last time was making lists with numbers in them. And now what we're going to do is we're going to making lists that are more complicated. So for example, if we use this example, here we said this is the function that plots a graph. If we use the table command with that, it's going to create n goes from 0 to 10 graphs of the function x to the n. So this is the function x to the 0, x to the 1, x squared, x cubed. These are your functions that you're used to seeing. You can use Mathematica to use the table command to create a list of colors. So if we wanted some nice colors in a rainbow pattern, there's a function called color data. There are many different types of color schemes. So click on the I button here and you'll see a bunch more. It doesn't show up. As you hover over this, there's an I button that appears. If you click on that, you'll go directly to the documentation center and you'll see a bunch of things about what types of colors there are. If we change this to being, instead of 0.1, so think about what this is doing. This is saying start with x is equal to 0, go to x is equal to 1 by increments of 0.1. So that's giving us x is 0, x is 0.1, x is 0.2, x is 0.3, etc. If we want more colors on the rainbow, we can change this 0.1 to 0.05, and then there'll be 21 different colors, right? 21 because 0.05 is 1/20th, and we're starting with 0 and we're ending in 1, so there's actually 21 different colors. And remember, we can check to see how long that is by typing length. So let's call this colors. Colors is this, length of colors, and there are indeed 21 colors in that list. We can also look at the periodic table of the elements. So here we're pulling in information from Wolfram's information online. And look, here's the first 100 elements of the periodic table. And if you wanted to, for example, look to see what those looked like, or wanted some more information, if you explore element data, you can then figure out what other words you can put here next to I. Let's talk about something that we're going to head more in that direction for the second third of class. Let's say we wanted to learn about the vertices of a polygon. Well, a polygon of a regular polygon has vertices that are equally spaced around the unit circle. So what I'm doing here is I'm creating the points on a circle. If you think back to parametric equations, those are cosine x, sine of x. So if we equally space points around the circle, the circle has 2 pi radians in it, so we're going to divide by 6. And so if we evaluate this, this is going to give us the 6 coordinates that are equally spaced around the circle. This one is 1, 0. This is cosine of pi over 3 sine of pi over 3. This is cosine of 2 pi over 3 sine of 2 pi over 3, etc. And then to visualize a polygon with these coordinates, we use this method. So here we created a graph, a picture of a polygon that had 6 sides by letting this 6 be the denominator here. Remember, we took 2 pi, we divided by 6, and that gave us 6 equally spaced points around the outside of the polygon. So if we think about it and we wanted to make something that had 5 sides or 4 sides or 3 sides, we would just change what this number 6 is. And so let's create a list of these types of polygons, right? So the list of this type of polygon is going to, we have a function that creates this type of polygon. It's graphics of polygon of this table. Graphics of polygon of this table lets you create a hexagon. So what we'll do is we'll create a table of things that look like that. Right? So we need to think about, well, what's going to change? We need to come up with a pattern. What's going to change from a polygon with 6 sides to a polygon with 7 sides to a polygon with 8 sides? And if we think about it, the things that are going to change are this number 6 and this number 5. Right? So this number 6 was how we knew how to divide things into 6 pieces, and this number 5 was telling us that we wanted to start at point 0, go to point 1, point 2, point 3, point 4, point 5. That's going around the hexagon, and when we stop, we hit the polygon. We stop when we're right back to where we started. So in order to fix that with our graphics object and make this a table to create a whole bunch of other polygons, then we need to change this 6 to a number, the number of sides. Let's call it I. And we need to change the numbered vertices to go from 0 to 5. It has to go from 0 to that number of sides minus 1. And so if we evaluate this, we will then get the polygons, the triangle, 3 sides, I is 3, I is 4, I is 5, I is 6, and up to 10. And this is one of the few times when you can say I is and it still be grammatically correct. All right, so let me write a couple of notes. So a couple of notes is that a table object, a table command, maybe I should say the function in a table command can be anything. So here we put graphics, we put colors, you can put sounds, lots of different choices. The next thing we would say is when constructing the table command, make sure that determine so first create one instance of the correct syntax. Alright, so what do we do up here in this polygon? This is one instance of the correct syntax to get the hexagon working. Then figure out the structure of a second object, a second instance of the correct syntax. So in this case, if we had said, okay, I want to create a polygon that has 5 sides, I would have changed this 6 to a 5, this 6 to a 5, and this k to a 4. Oops. See, if it's 3, that's not right. But if k is 4, we get that. So we get our pentagon. And so once we figured out the structure of the second instance, use this to determine the pattern of how the syntax is a function, a changing variable, and use that variable to figure out the table command. Alright, so that's the first part. That's using table to do more complicated things. Another thing you can do is you can use table with more variables. So the table command can also create a list as a function of 2 or more variables changing at a time. So look at this example right here. So before we had table of something where we had one variable changing. And now when we have multiple variables changing, all you have to do is you have to just include additional variables in commas after the first one. So when I evaluate this, what do I get? Well, if we just had this first part, what would we have? We would have create a list of things that look like x times y, where x goes from 1 to 3. Well, when we put in 2 variables, what we have is then we're basically creating a table of values or an array of values of the form x times y, where x goes from 1 to 3 and y goes from 1 to 5. And you'll notice what the order is here. We see that everything in the first part of this list is the list where x is equal to 1. So this is x equals 1, y equals 1, 2, y equals 2, y equals 3, y equals 4, y equals 5. When x equals 2, we have x equals 2, y equals 1, y equals 2, y equals 3, y equals 4, y equals 5. And then we have x equals 3, this is x equals 3, x equals 3, y equals 1, y equals 2, y equals 3, y equals 4, and y equals 5. And so this is taking this list, this rule, and it's doing things for all values of x and all values of y. And you can see this basically makes a matrix or a list of lists. Alright, so let's look at some examples. Let's look and see what we can have. Alright, so here's the first example. So when you're reading a table command, you look and see this first part. That's the structure of the function. So when we do this, we get the table, and we're going to create a bunch of things that look like brace x comma y end brace. So it's basically creating some coordinate pairs. So these coordinate pairs, we have x values that go from 2 to 4, y values that go from 5 to 7. So when we evaluate it, we see that we're going to have this first list where all things look like 2, 5, 6, and 7. The second part is all things that look like 3, 5, 6, and 7. And the third thing is everything that looks like 4, 5, 6, 7. And so that's why we get this as our structure. All right, let's look at this one. Table integer string x Roman x20. Let's run it and see what it's doing. Okay. You're looking at these. Oh, look at that. I, IV, V, VI. These are the Roman numerals. So what this has done is it's taken x from 1 to 20 and it's given us what is the Roman numeral for those numbers from x goes to 20. So let's actually, why don't we change this and go up to 100, and then we can see all the different Roman numerals from 1 up to 100. play around with that if you want to and see what else you could learn. I guess if you are an American football fan, you would know, you'd be able to easily figure out what the next football Super Bowl would be, unless you're looking at this 50 years in the future. All right, so example 3.2.2, how would we generate different output? Okay, so if we wanted to generate an output, so I've put this in a nice structure so that we can see what's happening. The actual output is going to look like this, but if we look at this output, then what we'll see is, okay, so this is a list of lists. The first element is the thing that's changing. So everything in the first list looks like 0, comma something. Everything in the second list looks like 1, comma something. Everything in the third list looks like 2, comma something. So this should be a table command. This should look very similar to the thing we had above. X, comma y. X goes from 0 up to 2, and y goes from 0 up to 2. And that's going to give us this list. Uh-oh, where did the other output go? I guess it was an example. Here's this other. So now let's see what, look at this. We want a list that looks like, excuse me, 10, 100, 1,000, 10,000. Well, I'm thinking it's going to have to do something with this integer string. Okay, so let's look at this. What do we want? So, so this looks like these are words for each of these numbers. Let's see if Mathematica, let's see if words is an option here. Words is not an option here. So because it didn't work, let's go and let's figure out if there's some information about integer string. Let's see. So if I were to, so let me change the view here. So let me change this to integer string. So I'm going over to the help desk information. So I clicked on the information. I said, okay, so let me learn more about integer string. When I went and I learned more about integer string, it gave me a whole bunch of details about what are the options here. So I could change the integer and figure out what the Greek numeral value is, or the simplified Chinese value of these words. But this doesn't actually seem to be useful. So I'm going to go down to the bottom of the documentation center thing here and look for other things that might be related. In this case, integer name seems like it's a useful thing. And when I look at this, I see, oh, when you do integer name of a number, it gives you what the words are for that number. All right, so let me close this. And we want to remember integer name. So if I close this and I go back to our thing, we didn't want integer string, we want integer name of x. Well, x goes up to 100. And that's going to give us the names of all the numbers from 1 up to 100. Okay, good. So now we know the right command. So maybe we'll write ourselves a little note here and says, so integer name takes takes a number and gives out its English name. If you go to the documentation, you can see that you can actually get other names other than English. But let's compare that to what we wanted. What we wanted was the list 10, 100, 1,000, 10,000. So what are those numbers? Those numbers look like this: 10, 100, 1,000, 10,000. And so we have to figure out what pattern these numbers make. So what we want is we want something that looks like integer name of 10, integer name of 100, integer name of 1,000, and integer name of 10,000. So what's the structure of these? The structure of these, this is 10 to the 1, this is 10 squared, this is 10 cubed, and this is 10 to the 4th. Okay, so what that means is we need to figure out, so this is telling us to create this list, we want to create something that looks like table of 10 to the I, where I goes from 1 to 4. That gives us those. And because we wanted this list of names, then we can put integer name of this. Actually, let me keep this. This was a useful thing to know. We'll copy, we'll paste it, and we'll put down here integer name of this. And we'll get exactly what we were looking for. This one says 1,000. This is 10,000. There's probably some option here to allow you to get exactly this. So you'll go back to the documentation center, explore the options, and figure out the one that does exactly what you want it to do.